So I will continue my video session for Cambridge IGCSE, and I was doing May, June 2025. The syllabus code is 0620 for chemistry, and this will be the last paper 6 status alternative to practical, and we have 63 now. I'm not going to read the instructions as you all are aware about the instructions. Like you know that calculator, you can use calculator, the total mark is 40. Notes for using qualitative analysis will be provided like this. Contains test for anions, cations, test for gases as well as clean test. So let's start the paper. So here's question number 1. Fermentation is a process in which yeast is used to convert aqueous glucose to ethanol and carbon dioxide. Fermentation takes place at a temperature of between 25 degrees centigrade and 35 degrees centigrade. Here's the reaction equation. C6H12O6 aqueous gives 2C2H5OH aqueous plus 2CO2 gas. A student uses the apparatus shown in figure 1.1 to make carbon dioxide by fermentation. So here's the whole setup, that is figure 1.1. A, name the items of apparatus labeled A and B in figure 1.1. You see, A is conical flask and B is gas syringe. So you write conical flask here. And gas syringe for B. Part B. Suggest why a water bath is used. If you look at the question, they have mentioned the temperature, that is, you have to maintain the temperature between 25 and 35 degrees centigrade. And if you have water bath, you can maintain it more properly. So that you can keep the contents of the flask between temperature of 25 and 35 degrees centigrade. To keep the contents of the flask between temperature of 25 and 35 degrees centigrade. Part C. The student measures the volume of gas that is collected of every 10 minutes for 90 minutes. The results are shown in figure 1.2. So we have time on x-axis and volume of gas collected in centimeter cube on y-axis. Describe how the results in figure 1.2 show that the fermentation is not complete after 90 minutes. If you look at the graph, there's a volume. It's not becoming constant after 90 minutes. So you're going to write gas volume does not become constant. You can even write or horizontal. Or you can even write or gas volume is still increasing.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring, from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
Part D, the student repeats the experiment using the apparatus shown in figure 1.3. So here's a figure 1.3. See the apparatus. We have aqueous glucose and yeast, water bath, and this lime water on the right hand side. 1. State what happens to the appearance of the lime water during fermentation. You see the carbon dioxide is produced here. The carbon dioxide, if it passes through lime water, it will turn to milky or cloudy. You can even check it from notes for qualitative analysis. Carbon dioxide, test for carbon dioxide gas. Here's a carbon dioxide test. It turns lime water milky. So you write turns milky or cloudy. Or to state one observation the student would make that shows that fermentation is complete. So during the reaction, carbon dioxide is produced, which is marked by the fizzing or bubbling. So there won't be any bubbles once the fermentation is complete. So you write no more bubbles produced. No more bubbles produced. E. State the method the student should use to obtain ethanol from the fermentation mixture. So in the fermentation mixture, we will be left with ethanol plus water. And you know that this mixture is a miscible liquid, mixture of miscible liquids. What are miscible liquids? Miscible liquids are those liquids which mixes into each other. So the method we are going to use for this is fractional distillation. So you write fractional distillation. Here's question number 2. Student investigates how the rate of reaction between dilute hydrochloric acid and aqueous sodium thiosulfate changes as the concentration of the aqueous sodium thiosulfate decreases. During the reaction, the solution slowly becomes cloudy. As the solution becomes cloudy, it becomes more difficult to see through the solution. The student does 5 experiments. Experiment 1. Use a 50 centimeter cube measuring cylinder to pour 50 centimeter cube of aqueous sodium thiosulfate into a 100 centimeter cube beaker. Use a 10 centimeter cube measuring cylinder to pour 5 centimeter cube of dilute hydrochloric acid into the beaker containing the aqueous sodium thiosulfate. Immediately start a stopwatch and stir the contents of the mixture. Stand the beaker on a printed sheet and look down from above the beaker as shown in figure 2.1. Here's figure 2.1. You see in the beaker we have aqueous sodium thiosulfate and dilute hydrochloric acid mixture. This is 100 centimeter cube beaker. Below it there is a printed sheet with printed text. When the text on the printed sheet is not visible, stop the stopwatch and record the time to the nearest whole number of seconds. Empty the contents of the beaker and rinse the beaker with distilled water. Experiment 2. Repeat experiment 1 using 40 centimeter cube of aqueous sodium thiosulfate instead of 50 centimeter cube. Use a 50 centimeter cube measuring cylinder to add 10 centimeter cube of distilled water to the beaker before adding the dilute hydrochloric acid. Experiment 3. Repeat experiment 2 using, this time they are using 30 centimeter cube of aqueous sodium thiosulfate and 20 centimeter cube of distilled water. You see the volume, they are decreasing the volume of sodium thiosulfate each experiment and increasing the volume of distilled water. So for experiment 4, this time they use 25 centimeter cube of aqueous sodium thiosulfate and 25 centimeter cube of distilled water. In experiment 5, they will use 20 centimeter cube of aqueous sodium thiosulfate and 30 centimeter cube of distilled water. User information in the description of the experiments and the stopwatch diagrams to complete table 2.1. So for the volume, we have started with the volume of 50 centimeter cube sodium thiosulfate 0. volume of distilled water. So in experiment 2, what they are using, they have used 40 sodium thiosulfate, then 10 will be the volume of distilled water. What about hydrochloric acid, the volume of hydrochloric acid is constant, that is 5. So experiment 3, they have used 30 to 20 ratio, 30 sodium thiosulfate and 20 for distilled water. Again, we are having 5 centimeter cube of hydrochloric acid for experiment 4. This time 25. Hydrochloric acid, again 5. Last one, we have 20 and 30 and 5. Now let's look at the time. First, we are having seconds only, that is 30 seconds. You see, it's 30 seconds. What about second one? If you look at this, 5, 6, 7, 37. So you have 37 seconds. Experiment 3. Now this time you are having 45, 46, 47, 48, 49. This will be 49 seconds. So I will write 49. Experiment 4, it must be 59. 59 seconds. Last experiment. Now we have 1 minute. 1 minute and 14 seconds. So what you are going to do? Add 60 plus 14. Sorry, it's 13. It's not 14. It's 13. So we have 73 seconds for this one. Write a suitable scale on the y-axis and plot the results from experiment 1 to 5 on figure 2.2. So here's the graph. We have volume of aqueous sodium thiosulfate in centimeter cube on x-axis. This one is x-axis. And y-axis, what we are having? We are having time taken for text to not be visible in second. So we have 10, 20. So I will write 30 here, 40, 50, 60, 70, 80, 90. So I have taken the 10 here on top, that is above 20. So you will get the graph like this in the end if you plot the values. So you will get the graph like exactly like this. Don't worry about the position of these two. You'll be starting from here. Moving to next part. Let us see the relative rate of reaction in each experiment is calculated using the equation shown. Relative rate of reaction is equal to 1 divided by time taken. 1. Calculate the relative rate of reaction experiment 1. Do not give units for your answer. No need to give units as they are saying. For experiment 1, what you will be getting? We will get 0.033. 0.033. So 1 divided by time taken. So here, the time taken is, you can see, it's 30. So 1 divided by 30. 0.033. Two, state in which experiment 1, 2, 3, 4, or 5 the relative rate of reaction was greatest. So if you will show the calculation for each experiment, for experiment 1, it's already there, 0.033. So for experiment 2, what do you need to do? Divide 1 by 37. And you will get 0.027. 0.027. In the same way, for experiment 3, you need to divide 1 by 49. You will get 0.0204. For experiment 4, 1 divided by 59 will get 0.016. For experiment 5, you will get 1 divided by 73, 0.013. So they are saying rate of reaction was greatest. Definitely it's experiment 1. So you'll write experiment 1 here. B. In each experiment, the total volume of aqueous sodium sulfate and distilled water is constant. One, calculate the volume of distilled water needed when the volume of aqueous sodium sulfate is 37 centimeter cube. Look at the graph. So here we are having 37. 37 will be the volume here for sodium thiosulfate. So they are asking the volume of distilled water. So we are getting 50 all the time. So simply what you have to do, 50 subtract from 37 from 50. What you will get? You will get 13. So 13 will be the volume. 2. From your graph in figure 2.2, reduce the time for the text not to be visible when the volume of aqueous sodium sulfate is 37 centimeter cube. Show clearly on figure 2.2 how you worked out your answer. So this will be the final position of the graph obtained for 37 centimeter cube of aqueous sodium thiosulfate. The time, it's around 38 or 39. It's around 38, 39. It's not exactly here. 38 or 39. Should be below 40. Below 40. 38 or 39. Number 3, explain why the total volume of aqueous sodium sulfate and distilled water is kept constant. You see the concentration of HCl remains same in all experiments. This will be the reason. Concentration of hydrochloric acid remain same in all experiments. That's why the total volume should be kept constant. E1, state why measuring the volume of dilute hydrochloric acid with a burette instead of a measuring cylinder would be an improvement. Burette, it's having a higher accuracy than measuring cylinder. So you write burettes have higher accuracy than measuring cylinders. 2. Explain why it is not possible to use a volumetric pipette to measure the volume of aqueous sodium thiosulfate in each experiment. You see the volume of sodium thiosulfate is not constant or it's not fixed. That's why we need to use a burette, not volumetric pipette. Volume of aqueous sodium thiosulfate is not constant or fixed. F. Explain why it is important not to change the size of the beaker to a larger beaker during the investigation. So this will definitely change the depth as the size of beaker changes. So therefore the time measured also changes. So you write depth will change with the size of beaker, and therefore the time measured also changes. Going to question number 3. A student tests two solids, solid L and solid M. Test on solid L. Solid L is hydrated aluminum chloride. The student dissolves solid L in distilled water to form solution L. Solution L is divided into 4 approximately equal portions. A. To the first portion of solution L, the student adds aqueous sodium hydroxide dropwise and then in excess. Observations when added dropwise and observations in excess. So for this one, we need to look at the qualitative analysis list, and this time I need to look at the test for the cations. We have aluminum plus here. So with sodium hydroxide, we'll get white precipitate, which is soluble in excess. So we'll write white precipitate. What about the observation in excess? Soluble. Part B. To the second portion of solution L, the student adds aqueous ammonia dropwise and then in aqueous. Observations when added dropwise, then observation in excess. If you look at this, there will be white PPT, which is insoluble in excess. So you write white precipitate. Observation in excess, we will write insoluble. This will be insoluble in excess, or you can even write no change. C. To the third portion of solution L, the student adds about 1 centimeter cube of dilute nitric acid, followed by a few drops of aqueous silver nitrate. This must be the test for the halide ions. If you look at the test here, it's for the halide ions. So we are having aluminum chloride. So if you look at the list, it will give the test for chloride ion, which is white precipitate. So you're going to write white precipitate here in the observations. D. To the fourth portion of solution L, the student adds about 1 centimeter cube of dilute nitric acid, followed by a few drops of aqueous barium nitrate. This must be the test for the sulfate ion. You see, this is the test for sulfate ion here. And we don't have any sulfate ion here. If sulfate ion was there, then we will be getting white precipitate. So what you're going to write, you need to write no change. Moving to next part, that is the test on solid M. Table 3.1 shows the test and the students' observations for solid M. Here's table 3.1. Do a flame test on solid M. What we are getting? Light green colored flame. So for light green colored flame, if you look at the flame test, light green colored flame. So you have barium here. Must be barium of barium +2. Test 2. Dissolve the remaining solid M in water to form solution M. Divide solution M into 3 portions. To the first portion of solution M, add about 1 centimeter cube of aqueous sodium hydroxide. No visible change. Okay. Test 3. To the second portion of solution M, add about 1 centimeter cube of aqueous sodium hydroxide and a piece of aluminum foil. Warm the mixture and test any gas given off. Effervescence is seen. Damp red litmus paper turns blue. Effervescence, it indicates the gas produced here. And they are saying that red litmus paper is turning blue. So the gas produced that's turning litmus paper blue, it means that it must be ammonia gas due to ammonia gas, NH3 gas. Test 4. To the third portion of solution M, add about 1 centimeter cube of dilute sulfuric acid. White precipitate forms. Now, if it contains, if you look at the test for the anions, here's the test. For anions, there's a sulfate test. So, if sulfate ion will be there, it will be reacting with the barium of barium nitrate to produce white precipitate. This one is of barium sulfate. White precipitate is of barium sulfate. So you see, we have already confirmed that we have Ba2 plus ion. So this must be reacting with the sulfate ion from sulfuric acid. So of BaSO4. So this must be due to barium reacting with the sulfate ion. So part E, identify the gas given off in test 3. So in test 3, the gas given off must be ammonia. If you look at the test for ammonia gas, turning damp red litmus paper blue. So the gas here, it must be ammonia. Ammonia or NH3. Now in F, identify solid M. So we have barium nitrate, NO3, because this test is of nitrate. We look at the taste test here for the anions. Is a test for anions. It gives ammonia gas. So it must be barium nitrate. So what you're going to write? You need to write either the charge or the name of the ions, that is barium ion, or Ba+2, and we are having nitrate or NO3 minus. You can even write the formula of barium nitrate. It must be BaNO3 whole twice. Barium is in group 2. Nitrate ion carries minus charge. Nitrate ion carries -1 charge. Barium is in group 2. Ignore the charges. These subscripts will be exchanged. Then you will be getting BaNO3 whole twice. Move to next question. Lead 2 chloride PbCl2 is an insoluble salt. Solid lead 2 chloride can be made by reacting aqueous sodium chloride with aqueous lead 2 nitrate. Here's the reaction equation. 2 moles of NaCl aqueous reacting with 1 mole of PbNO3 whole twice aqueous to produce 2 moles of NaNO3 aqueous plus PbCl2 solid. This one is insoluble. Describe how to make a pure dry sample of solid lead to chloride. You are provided with solid sodium chloride, solid lead to nitrate, distilled water, and common laboratory apparatus. This reaction is example of precipitation reaction. So you need to follow these steps for precipitation reaction. Total mark for this question is 6. So in order to gain 6 marks, we need to write any 6 points from this. Any 6 from these. So first of all, you have to add sodium chloride and lead nitrate to water. Remember, you have to name the container or instrument used from time to time in different steps. So I'm going to write add sodium chloride and lead nitrate to water. And you are taking all of these in the container, like name the container. So here the container, like you can use beaker or test tube in this case. Second, you can get mark for this if you write mix or shake. Mix or shake. Mix or shake to dissolve the contents. What else you do? You can even write mix the two reactants. Mix the two reactants. Then I want to get lead to chloride. So need to filter. Get lead to chloride. As residue. Then you can wash the residue with distilled water. Then you can dry the residue. Description of drying. So you can write in oven or use tissue paper. So you have point 1, 2, 3, 4, 5, 6, 7. So you can write any 6 from these. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.